Now let's look at something we haven't seen before, although I've made reference to it, and what are known as charged atoms. So atoms that have a charge. Whoops, let me write this capital. If an atom has a charge, it's no longer considered to be an atom, but an ion. Now let's look at atoms again. The number of protons determines the element. All sodium atoms have 11 protons in the nucleus. As soon as we see 11 protons, we know the symbol is going to be capital Na. In chemical changes, the protons don't change. They determine the identity of the atom, but the number of protons never change. However, electrons do move. And so electrons can be lost, as what happens to metals, or they can be gained, as what happens to nonmetals. And so when atoms lose or gain electrons, they gain a charge because now the number of protons and number of electrons aren't the same. When that happens, these are known as ions. So atoms can, and actually molecules too, can acquire a charge by gaining or losing electrons. And what that means is there's a difference between the number of protons and number of electrons, and so there's going to be an overall charge. Ions that have a positive charge are known as cations, not cations, cations. And what this means is there are more protons than electrons, and they occur when an atom loses electrons, such as metal atoms. Ions that have a negative charge are called anions. That means they have more electrons than protons, and this happens when an atom gains electrons, like nonmetals. Chemically, ions are much different than neutral atoms. And let's think about this. Here's sodium as an element, practically exploding in water. Well, we know that sodium is an important part of our diet, and it's in our bloodstream, it's in our cells. Clearly, it is not this sodium. It is sodium in the ion form. So sodium goes from a metal in the elemental form that's shiny, low density, floats on water, catches on fire when it touches water, to an ion that is actually very unreactive and necessary for a lot of biological processes. Now let's look at anions. We know that nonmetals form anions. And we can tell how many extra electrons an atom or an ion has than protons by looking at the charge. And let's look at this balanced equation here. You'll need to know how to do this for some of your homework. If you have a fluorine atom and you add 1 electron to that fluorine atom, you're going to end up with a -1 charge. Here, the number of protons and electrons are the same. If we add an electron, we'll have an excess of electrons, 1 extra. Now, in chemistry, oftentimes when the number 1 is supposed to be there, we don't write it. So even though there's not a 1, it means -1. And let's look at an oxygen atom gaining 2 electrons. When that happens, we have a -2 charge. Now notice on both sides of the equation, both sides of the arrow, the total charge is the same. If I look on the left-hand side here, I have 1 negative charge, and over here I have 1 negative charge. Here, I have 2 negative charges, and here I have 2 negative charges. The periodic table can help us know the charges of some elements that form ions. Now over here in this part of the periodic table, to the left of our staircase, everything's going to form a positive charge because that's what metals do. Our first row, alkali metals, will always be +1 when they form an ion. Our second column, I call this a row, I'm sorry, it's a column. Our second column will always be +2 when they form ions. And then over here, aluminum, 1, 2, skipping this block here, 3, will always be +3. Now we were talking about anions. Anions have negative charge, and they're going to be over here. Noble gases will not form anions. They're very stable and don't want any extra electrons. This family right here, the halogens, wants to gain as many electrons as it can to have the same number as the noble gases. So we can tell what its charge is going to be by how far away it is from the noble gases. This family here is 1 away from the noble gases, so halogens always form -1 charge. Oxygen family, -2. It's 2 away from the halogens. 2 away from the noble gases. Nitrogen family, -3. And this is really as far as we go. After 3, it's really hard for atoms to hold on to extra electrons. So let's look at the periodic table with the symbols on it. +1, +2, +3. -1, -2, -3. So here it is written out with the symbols of the elements. When we write a charge, we always write the charge in the upper right-hand corner. And it doesn't matter if the charge comes after or before the number. Now, these two ions do form +3, but they can also form other charges. Aluminum always forms +3. +1, +2, -1, -2, -3. Now let's get back to looking at our balanced equation here. For metals, we know that metals form cations, meaning they lose electrons when they react chemically. And we're going to again look at our balanced equation. Here's sodium. Sodium has a +1 charge. That means it has lost 1 electron. And we can figure out what number needs to be here by looking at our charge, because the total charge on this side has got to equal this side, which is 0. So if I have +1, I have to have a -1 so that it can equal this side. Here I have calcium, and we know it forms a +2 cation, and I have to have 2 electrons, because if I have +2, I need a -2 to cancel it out to equal the neutral charge over here. So let's look at this practice problem. Let's find the number of protons and electrons in the calcium ion. So we do this by looking at our periodic table. Anytime we see the symbol Ca, that means calcium. So that means we have to have 20 protons. So that means we have a charge of +20. My total charge is +2. How many electrons do I have? Well, I have to subtract 18 from 20 to get the charge of +2. So I have 18 electrons. Another way you can remember this is if you have a positive charge, that means you have more protons. And whatever that charge is, that's how many more protons you have than electrons. So we have +2, so that means we have 2 more protons than electrons. And if we have 20 protons, which we always do when we see the symbol, 2 more than 18 is 20. So take the time to fill in this table. Just pause the voice lecture for a second and then start it again when you have your answers. So what I do when I fill out these tables is I always fill out the protons first, because I need to find where they are in the periodic table, and then I write down the number of protons. Once you know the symbol, the number of protons will be the atomic number. So chlorine always has 17 protons, potassium always has 19 protons, sulfur always has 16, and strontium always has 38. Then I look at the charge and see whether it's negative or positive. If it's negative, I have more electrons. And it's -1, that means I have 1 more electron, so I have 18 electrons. Potassium, it's a positive charge, +1. That means I have 1 more proton than electron. So if I have 19 protons, I must only have 18 electrons. Sulfur, my charge is negative, so that means I have more electrons. Sulfur must have gained these 2 electrons. We don't really care how, but we're just looking at the overall charge at this point. So if there are 16 protons, I must have 2 more electrons to get that -2 charge. So I have 18 electrons. Strontium has a +2 charge. that means I have 2 more protons than electrons. So if I have 38 protons, I have 36 electrons. These are very stable electron configurations, and if you notice, these are the same number of electrons that the noble gases closest to these elements have.